Alright, hello everyone. This is problem 14 from a Physics C Mechanics multiple choice test, an AP test that is. This is one of a series of 3 questions relating to this scenario. So I'm going to read the scenario and then the question, talk about the concepts, and then go through solving it with you. You can pause at any time if you'd like to try to solve it yourself. So this is the scenario. A ball of mass 2.0 kilograms is thrown vertically upwards from the top of a building. The ball's velocity v is given as a function of time t by the equation v of t is equal to r minus st, where r is equal to 5 meters per second and s is equal to 10 meters per second squared. The positive direction is upward. So 14 is asking us, what is the ball's acceleration at time t equals 1 second? And we are given an equation for velocity. It's a little bit odd that it tells us the equation and then tells us what the variable equals instead of just giving us the equation. I guess it wants us to plug the stuff in, but let's do that now as our very first thing, because all of that information is given to us. So r is 5, and then s is 10, and then we have t. Alright, so this is our equation for velocity, and it's asking us for acceleration. So how do we get to acceleration from velocity? Answer, we take the derivative. So to take the derivative of something, we're going to take the first derivative of velocity, also known as acceleration, is, so since this is adding a negative, we can first take the derivative of 5 and then add the derivative of negative 10t to that. So the derivative of 5 with respect to t is 0. So I'm just not going to write that. We know it's 0. And then the derivative of negative 10t is going to be negative 10. So our function for acceleration is a constant. It's not changing. So this part of the question, what is the ball's acceleration at time t equals 1 second? It doesn't matter what time it's at. The acceleration is going to be constant at all times. The acceleration is going to be negative 10, which happens to make perfect sense because if you're throwing something on Earth upwards, it's going to be constantly accelerating at the rate of g, the gravitational constant, which is 9.81 or about 10. And the positive direction is upwards, it's accelerating downwards, so negative. It matches up perfectly with what we know. We could probably answer this question even without doing any math, just by the fact that we know that g, the gravitational constant on Earth, is 9.81. So this is a pretty simple one compared to some of the others. It gives us a nice reprieve. But our answer here is A, negative 10 meters per second squared. Yeah, let's see. It's a pretty straightforward problem. Alright. Let's talk about derivatives a little bit more in this video. So let's talk about the rules of derivatives. So here, since 5 is already a constant, the derivative of that is going to be 0. So when you're taking the derivative of like a number to a power, or a variable to a power, since this is t to the first power, 10 times t to the first power, what you do is you multiply the power times the coefficient and subtract 1 from the power. So 1 times 10 times t to the 1 minus 1 is equal to 10 times t to the 0, and anything to the 0 is 1, so 10. That's a very easy derivative. You can look at some more complicated ones, for example, like 7 thirds I'll just write x to the 8. So the way we're going to do this is we're going to say 8 times 7/3 x to the 8 minus 1. Sorry, it's hard for me to write this on the slant, but that's what I'm writing. So 8 times 7, 56/3, x to the 8 minus 1 is 7. This is the derivative of this. So again, that's how to solve this problem. Little quick lesson in simple derivatives, but there it is. We're going to move on now to problem 15. All right, check back in. Thanks for watching. Like and comment.